Okay, let's start this question. 10/2022. It's a RAM question. Sahil is taking off a RAM. Goes like that. Hit the place below he started. So these sums are very common. Okay. This. Okay. I want to see whether he can clear 100 meters or not. Where is 100 meters? So the easiest way that I recommend is we'll put A2, B is a little lower level. Straight away we'll put the equation. Before that, there's horizontal vertical component stories there. We'll finish that too. Everyday part. 25 degrees. Calculate horizontal and vertical. Horizontal component will be 35 cos 25. Vertical component is 35 sine 25. Very common sum. Next part they are telling. Yeah. Always we in our calculation we neglect resistance. So therefore, horizontal will move in constant velocity downwards, vertical it will accelerate 9.8. Whether it's going up or down, it doesn't matter. Acceleration is downward 9.81. While it's going up, it's a vertical projection at an angle or horizontal projection. Vertical motion, downward acceleration is throughout the motion, 9.81. Horizontal motion, acceleration will be 0. Okay. Now what I'll do is take it like that. This is my point A. That's my point B. A to B, I'm putting downward. The displacement is downward. I'm going to put S equals UT plus half AT squared downward. I'll be finding the time. After finding the time, I can put S equals UT horizontal. Half AT squared. Put in downward. Downward displacement is 3 meters. It's going down. The ramp might be 3 meters, 3 meters. Initial upward velocity, since I'm putting down, it should be negative minus 35 angle this doing sine 25 t plus gravity will be plus half 9.81 t square. So I'll take everything into this side. 9.81 divided by 2 is 4.905 t squared. We calculate how much is 35 sine 25. 35 sine 25 is 14.79 minus 14.79 8 minus 3. Okay, then we'll use the quadratic mode in the calculation. You don't have to show the working of the quadratic formula if you want to show mathematics paper, therefore they don't check that. Okay. We type in this 14.05 minus 1.14 minus 3.2 seconds one answer. Seconds. Another one is minus 0.19 seconds. So we get a positive answer. 0.32 seconds. Now I'll put the equation horizontally. S equals ut. Horizontally, we'll put S equals ut. So horizontal velocity will be 35 cos 25. We found it in the earlier part. 35 cos 25 into 3.2. 35 cos 25 into 3.2. 101.5. It'll clear. 100 meters will be 101.5 meters. Then we can say 101 point, say its total is 101 meter is larger than 100 meters. Therefore, we will clear the river. Next part. There's another way of doing it. I can put from A to C and C to B. I'll be sending another video. In that calculation also, I am doing it in both ways, but this one I am doing it like that. So this way is fine. This is, for A to C you can put and C to B you can put. There's another video coming parallel to that. In that working will be the similar ramps. To the next part. Explain how the air resistance would affect the jump. What will happen? So horizontally now we consider it's going constant speed, horizontally decelerate. Horizontally it will decelerate. So therefore, during that time it will travel less horizontal distance. And the flight time will also decrease. Right? Vertically also now it's on 9.8 on vertically, it will slow down at a higher rate. So that time also will be less now. Flight time will be less. For example, imagine you throw a leather ball. Now these motions under gravity are independent of mass. Can you see? We never consider mass. If you throw a leather ball or a ping pong ball at the same angle, our calculation will show the same range. Same angle, same speed. If you throw a leather ball or ping pong ball, our calculation will show the same range. What will happen to leather ball? Leather ball will have a greater range, greater time of flight. It will be there in for a longer period of time because it has a higher mass. It has more fine tip range. It can do more work again air resistance. Less air resistance is experienced by the leather ball. What will happen to the ping pong ball if I throw it? It will quickly drop. No, it will drop. Flight time also less. So mention that also. Flight time will be less than the value we calculated. That also will reduce the range. With flight time we calculate 3.2, it will take less than 3.2 seconds to reach the ground. Why? Vertically it will decelerate. So vertical deceleration will be not now not 9.8, right? It's different. Okay. Then vertically it will slow down while it's going up. It can't reach the maximum height like earlier. Then horizontally also, again, horizontal. Vertically it will you can't say vertical just this, the vertical decelerate with a greater value than 9.8. Acceleration also there, weight was acting down, the drag also accelerate. While it's going up, tilt like that, while it's going up, vertically it will decelerate more than 9.81. So the flight time will be less. Horizontal it will slow down. Therefore, both will reduce the range. Range will be less. So most probably will take the water, but we don't know. We can't comment on that. We say range will be less. That's done. It is not clear, again ask in the class.